Thanks, Anthony. Good afternoon, everyone, and thank you for attending. We're very happy to talk to you about our project today. I'm Tim Plant, and I'll let the rest of the team introduce themselves.
I'm Maggie Brewer.
I'm Michelle Morrison.
And I'm Laura Doherty.
And collectively, we are Team Wetland. The project we've been working on is the use of WESP in New Brunswick wetland policy. We'll begin with providing some background information as well as describing our project tasks, our team's main goal and objectives, as well as dive deeper into the WESP procedure itself. Then we'll discuss the different aspects of our project, including repeatability and improvement research, which falls under objectives 1 and 2, respectively, and the approaches we established to use our data in management context, namely the Wetland Priority Framework and the Wetland Priority Map. Then we'll wrap up with a quick summary. Wetlands and wetland functions are two terms you'll hear a lot in this presentation, so we decided to start off with defining exactly what those terms mean. According to the provincial definition, a wetland is land that has water at, near, or above the surface for long enough for vegetation and soil to become adapted to wet conditions. A wetland function is a naturally occurring service that wetlands provide. Some examples of that are water storage and habitat, as well as many others that we'll get into. And they're important to monitor and protect because of their ecological, economic, social, hydrological, physical, and cultural value. The current setting around wetland management in New Brunswick today involves some pressure to develop wetlands within the province. The issue at hand is, amongst the development, there currently is no means to measure or monitor wetland functions. Since the province is mandated to conserve both wetlands and their functions, a method for functional assessments is needed. Our project involves evaluating the use of a new method of functional assessment called the Wetland Ecosystem Services Protocol. Our clients are the Department of Environment and Local Government, and their request was for us to test the repeatability and improve the process of WESP. In addition, we also wanted to look further into how the data for WESP can be used in a wetland management context. With this information, our main goal is to verify the usefulness and suitability of WESP-AC New Brunswick wetland decisions. Our objectives we identified to help us reach this goal are to determine if WESP-AC is a useful tool for assessing wetland function, to identify potential improvements to WESP-AC, and to demonstrate how we can use WESP for prioritizing wetlands for protection. The Wetland Ecosystem Services Protocol was authored by Dr. Paul Adamus. It's a wetland assessment tool that accounts for 17 wetland functions. It does so by assigning a theoretical score from 0 to 10, which indicates how well a given wetland performs those functions. One major benefit is the assessment itself only takes a few hours to complete, saving time and money. It is also based on decades of research, with the first journal article on indicator function relationships dating back to 1983, and the WESP assessment itself has been in existence since 2006. Another great property of WESP is that it can be adapted to the area of its intended use. For New Brunswick, this includes all non-tidal wetlands within the province. The regionalization process is completed through the use of calibration sites, whose purpose is to define the range of all future wetland assessment scores. In other words, all WESP assessments done after the calibration sites fall within the function ranges defined by the calibration sites. The calibration sites are also intended to capture as much diversity of wetlands as possible. After the regionalization is complete, an addition to the acronym is added to indicate where WESP is being used. In our case, AC stands for Atlantic Canada. The actual assessment itself includes 3 components. The first one is the office sheet, which contains 39 questions, or indicators as they're called in the manual, and covers topics such as area, distance, location, and landscape. And the answers to those are based on using aerial photography and using computer spatial measuring tools like Google Earth Pro or ArcGIS. The second component is the field sheet, which has 66 indicators. It covers topics such as vegetation, soil, topography, and water, and is completed on-site using visual estimation. And lastly, the stressor form, which contains 5 indicators and covers any anthropogenic threats that might be in the area. That's also completed on site and based on presence. Once the assessment is finished, all of the data gathered gets entered into its corresponding equations for each function, and a normalized score of 0 to 10 is produced for each function. And this table here summarizes the functions that WESP assesses into 3 kind of broad categories. And now that you have a bit of background information, we'll discuss how we use WESP in our project.
So I'm going to talk to you guys about our first 2 objectives for this project. I went backwards, sorry. So our first objective was to determine if WESP is a useful tool for assessing wetland function in New Brunswick. Our design for accomplishing this objective was to assess the precision of WESP by comparing the function scores of multiple assessors. This was carried out by quantifying the precision of WESP through doing a repeatability assessment and then analyzing the results from that. Before we were able to do a repeatability analysis, we first needed to collect our data. So this was done by 5 students and 2 experts on wetland from the Department of Environment and Local Government who assessed the wetlands. All of the people doing the assessments did them independently without talking to eliminate bias from that. The 7 individuals assessed 6 wetlands, and the wetlands were assessed between October and November of last year. So these are a table summarizing our results from our analysis. We found that the students' WESP results to be much more variable than the expert WESP results. And in order to determine if our variation we found was acceptable, we needed to determine a threshold for variation. We determined this threshold by talking to the developer of WESP, who told us about a method he has used in previous repeatability assessments. And that is if the coefficient of variation among assessors is less than the variation among sites, then the variation is deemed acceptable. This is because in this situation, the results of multiple people are more indicative of one wetland than of different wetlands. So our study found the variation among assessors to be less than among sites, and therefore acceptable by these standards. However, we recognize that 40% variation is still significant and should be decreased, which we will address further in this presentation. So this graph shows, the previous graph showed a group of functions together, whereas this graph shows the functions divided up and the variation for each of them. You can see that by the graph that most functions have a similar variation, but there are some extreme outliers, such as pollinator habitat and anadromous fish habitat, which has high variation. So we're going to look at these independently. So these graphs break down the 2 functions with the most extreme variations by each wetland that was assessed. The green bars show the mean function scores, with the black bars showing the standard deviation of those scores. The left graph displays the low variation in pollinator habitat scores between assessors, whereas the right graph shows the high variation in anadromous fish habitat scores between assessors, as the answers deviated greatly from the mean. The large variation is a result of a question regarding the presence of an outflow being answered differently depending on which area of the wetland the assessors went to. So now that we have identified the variation, I'm going to discuss our second objective, which was to suggest potential improvements to WESP. This was done by identifying the sources of variation in our answers from the WESP to the indicator questions, and then suggest changes to decrease these variations. The first thing that we identified that impacted variation in the answers to the indicator questions was the search effort. In the manual for WESP, it recommends that when completing a WESP assessment, assessors must visit as much of the wetland as possible. We found from our results that searching different areas of the wetland resulted in different answers to the questions because you saw different parts of the wetland. An example of this impact is in question 42, which asks about water outflow, which was answered very differently by individuals depending on if they visited the part of the wetland that contained the outflow or not. In turn, these variable answers to the outflow presence impacted the anadromous fish habitat score, as shown in the previous example. In response to this, our recommendation is that wetlands to be only assessed with WESP after an individual has searched all of the wetland. Our second identified impact on variation between assessors was seasonal bias. The WESP manual states that when conducting a WESP assessment, wetlands should be visited during the growing season. However, due to the timing of this project, we visited the wetlands in the fall. From our data, we found that 17% of the indicator questions were impacted by the time of year, which was mainly due to the vegetation that was dead and therefore hard to identify. These 11 questions are included in the calculations of 88% of the function scores. Because of this impact, we recommend that WESP assessments be done only in the growing season when the results are going to be used in a professional setting. The next impact that we assessed, or that we identified, was the amount of timing a trainer or assessor had. The WESP manual recommended that 2 to 3 days of training be done before you conduct WESP assessments. However, we received 7 hours of training. The experts having much more WESP training time than the students is potentially one of the reasons the expert assessors had approximately 5 times less variation in their scoring. This problem of training time is supported by other studies on similar wetland assessment methods. Our recommendations to this is that there be a mandatory 2 to 3 day training time, and that this training includes shadowing of the trainers in the wetlands so that students can get a sense of how they would answer the questions. Also, we recommend that the training be concluded with a test where the students conduct a WESP assessment on a wetland with known results and have their results compared to the known results. And we recommend that the training be required if the WESP results are going to be used in a professional setting. The final cause of variation we identified was problematic indicator questions. To quantify what we compared the indicator questions answers of the assessors and categorized them by low, medium, and high variation. So we quantified low variation as being when each person answered a question exactly the same or quite closely. Medium variation was when the responses were divided between 2 questions, but their answers were slightly different, so they were divided between. And high variation being when everyone answered a question very differently. We found that the student answers were about 20% variation for high. They received approximately 20% of their answers as having high variation. The main reason for this were questions that were unclearly worded. Also, things that required you to visualize slope and things that required you to visualize distance and area. So our recommendations to this for visualizing slope would be that there's a focus on this during the training time. So when you go to the wetland and are trained, you're taken to different areas with different slopes so you can get an idea of what the slopes really are. As well, we recommend there be a visual aid beside the WESP questions, something like you see here, that gives the assessors a guide for what different slopes look like when they're conducting their WESP assessments. To address the challenges associated with visualizing distance and area, we also recommend this be a focus of the training time, and that the questions that require a judgment of distance or area have a real-life association beside them in the WESP form. For instance, having questions that refer to the distance of 10 meters have an association, like 10 meters is the same as a school bus. This just gives the assessors something to compare to while in the field, since no actual measurements are taken during a WESP assessment. The suggestions that we have made would help WESP assessors answer indicator questions more precisely and likely reduce the variation in WESP results between individuals. Now I'm going to turn things over to Michelle, who's going to talk about our third objective.
So our third and final objective was to determine how WESP-AC could be used in prioritizing which wetlands should be protected within the province. And so this had 2 main components, method 1, which was the wetland priority framework, and method 2, which is the wetland priority map. So method 1 is essentially our suggested method for something consistent and systematic which focuses on which wetlands should be prioritized for protection. And it does this by comparing functions between wetlands on a watershed scale. Our framework compares each of the 17 WESP functions for a specific wetland to a threshold. So essentially, if the specific function value for a specified wetland exceeds the threshold, this means that this function is a priority for protection. And if it doesn't exceed the threshold, it's still important, it's just not a priority. So determining the threshold was fairly simple. It was essentially just the average of the function scores across the assessed wetlands for a specified watershed. And the framework determines a unique threshold for each of the 17 functions, as well as these thresholds are also unique for the watershed. So after the total number of functions that are prioritized for conservation have been determined, other priority factors need to be considered, and this is where weighting values can be applied. And for the focus of our project, we chose to focus on wetland type. But it's also important to address that this is only a framework, and the accuracy will be improved as more data is obtained. So to help you guys a little bit in understanding how our framework works, we're going to run through a small example taken from the Grand Bay Watershed. So instead of focusing on all 17 functions, we're just going to simplify it down to three functions across 3 sites. So as you can see, there are 3 different columns here for each of the sites. So there's a bog, marsh, swamp. And in these columns are the individual function scores that were obtained with the WESP assessment. So for each function, you need to determine the threshold, which is the average, and that's located on the far right. And then after you've determined the threshold, you can compare the individual function scores to the threshold. So for example, if you look at bog, its function score for water storage is 4.0. That means it exceeds the threshold and is therefore marked as a priority for protection. So after you've done this for each of the individual function scores, you can then take the total of the number of functions which have been marked as priorities for each site, and this gives something called the function priority count. And so after you've determined your function priority count, this is where weighting can be applied. So as I mentioned, we decided to focus on wetland type, and the weighting is applied to the total site score, and not the function score. So based on the 98 calibration sites, we determined that there were the highest percentage swamps and the fewest bogs, and therefore we gave bogs and fens a higher weighting because based on our data, they were rarer and therefore more vulnerable to being impacted by development. So essentially the weighting is very simple. It's just a multiplier. So there's a row here. Oh, that's the wrong thing. A row here where you put your weighting values in. So because bogs were 4 times as rare as the swamps, they have a multiplier of 4. Marshes were 2 times as rare, so they have a multiplier of 2. And this multiplier is applied to the function priority count to give you the total priority score, which is, as you can see, for bog and marsh, they are higher than swamp, and that means that these 2 sites would be prioritized for protection over the swamp. However, we do still have a few recommendations to make to improve our framework, and the first one would definitely be making it more representative by having additional data. And to make it more representative, we're suggesting that all of the wetlands within New Brunswick be classified based on their type. We're also suggesting an increased sample size, and originally we considered determining sample size by using a power analysis. However, this wouldn't work for us because we're considering multiple variables. So we have 17 functions and we have a maximum value range, so 1 to 10. So instead we took a method from the table of statisticians and for determining sample size for finite populations. And so obviously if you have a finite population, the optimal sample size would be the entire sample, which for Grand Bay Watershed is 487. However, we realize that's somewhat unrealistic with time. So we have 2 suggested sample sizes. So if you were to use a sample size of 216, that would give you a 95% confidence, which means that 1 out of every 20 in your sample has a potential to not be representative of what is there. Or if you would like to do something even less time consuming, then a sample size of 81 would be recommended, which would give you 90% confidence in your data, and that means that approximately 1 out of every 10 in your sample would be not representative of what is actually in the field. Our second recommendation would be to focus on obtaining WESP data for areas that are likely to be impacted by development. So we looked at that using GIS and focused on areas which are municipal development areas within New Brunswick. So the two municipal development areas or centers in the province are Fredericton and Moncton. Fredericton is on the left and Moncton is on the right. And we identified approximately 5 watersheds for each, which would be likely to be impacted by development. And then we're also recommending that WESP data would be obtained for areas of proposed industrial development, such as the Sisson Mine project. And our third recommendation would be adding additional weighting factors to the framework. So as we said, we only considered one, which was wetland type, but there's a number of others which would be important to include, such as how rare or threatened is the wetland type, the connectivity of the wetland, so how many other water bodies does it flow into, what is the functional replicability, so how easily are the functions in WESP replaced with constructed wetlands, and what are the social value or importance of a specific wetland in question. And then, so our wetland priority framework is used in coherence with the wetland priority map, which essentially what the map does is displays wetland parameters across New Brunswick, such as it identifies the best sites for specific functions, identifies the distribution of wetland type across the province, and also shows potential areas in which to avoid development. So this is an example. This shows trends in amphibian habitat. So this takes the function score for each of the 98 calibration sites and rates it as high, moderate, or low in function. You can also see here the distribution of wetland type across New Brunswick based on the 98 calibration sites. And this one shows the zones of restricted or limited development, which would include provincially significant wetlands, protected natural areas, and protected watersheds. However, we do still have some recommendations for mapping as well to improve it, which would include mapping projected industrial development projects, mapping the weighted values that are added to the framework as they're added, and also adding a layer to show where the critical habitat area in New Brunswick is located.
To summarize our project, our main goal was to identify the usefulness and suitability of WESP-AC in New Brunswick wetland decisions. Our objective 1 was to determine if WESP-AC is a useful tool for assessing wetland function. Objective 2 was to identify the potential improvements to WESP-AC. And objective 3 was to demonstrate how we could use WESP for prioritizing wetlands for protection. And our concluding results were WESP-AC did meet our repeatability standards, although it could have been better. And to address that, we've identified those problem areas and recommended steps to address those problems. And we also demonstrated how the data can be used for management purposes using our wetland priority framework and our wetland priority map. For some final recommendations, we'd like to see more studies conducted on WESP-AC accuracy by comparing WESP results to professional measurements. We would also like to see an improvement on the level of variation in WESP-AC answers. We would also like to see an improvement in the level of variation in WESP-AC answers. This can be done by applying a standard search effort, assessing during the growing season, more rigorous training, and some aids for some difficult to understand indicator questions. We'd also like to see more WESP assessments being done to make sure of a more representative sample with focus on assessments in developing areas, as well as creation of a more user-friendly interface, such as an app for phones or tablets, which would make the process easier when in the field. And last but not least, we'd like to thank everyone listed here for their insight and their opinions and helping us along the way to make this project what it is today. And also, thank you for listening. That concludes our presentation, and we'd like to open the floor to questions.